In this video, we are going to do the second part to the Lewis and Bohr models. I broke it up because the video was getting a little bit long. What I'm going to do is I'm just going to show you what real Bohr models look like, and I'm going to show you how to take a Bohr model and go backwards to get the symbol with the numbers. It's pretty easy, so it shouldn't take too long. So if you're looking at a Bohr model like this, the piece of information that identifies your element is the proton number. So what you do is, for this one, you would go to the periodic table and you would find element 10, because 10 protons means atomic number 10, which makes it neon. So I write the symbol in, neon 10. Next, it doesn't matter what step you do this in, but if you want to get the weight, it's easy. The weight is P and N added together. So 10 and 13 added together is 23. That's its mass. Now, the neon on the periodic table says its weight is 20. That's fine. This neon happens to be an isotope, so its weight is different. You just have to use it. Now, for the charge, we do know that we use P minus E equals C for charge. And in this case, we know the P. We don't know the C, and I can find the E just by adding up the configuration. 2 plus 8 plus 3 is 13E. So 10 minus 13 gives me my charge, -3. Now, some people may get confused and they'll say, but there's no -3 written in the top right-hand corner. I understand that. And again, I've told you this numerous times, that these numbers are oxidation states and we don't know what they are yet. They are going to come into play and they are related to this topic, but we're not going to learn them until we get a little bit more advanced and can actually understand what they truly mean. So, and that's number one. I'll go through the rest a little bit quicker and I'll put the periodic table away for that. So for this next one, it has 51 protons. So you find element 51, SB, 51. You add 51 and 87 together, 138. You add up the configuration, 2 plus 18, or 2 plus 8 plus 18 plus 18 plus 4, and it ends up being 50. So P minus E equals C, plus 1 is your charge. It's that simple. The next one, element 20, is calcium. 20 plus 21 gives me my mass, which is 41. I know that's different from the periodic table. That's totally fine. Add up the charge and you get 20 electrons. And for that one, I could just leave it blank, or I can write the 0 in. It's your choice for the 0, because the zeros can always be left off. And last one, element 9 makes it fluorine. It has 11 neutrons, so 9 and 11 added together is 20. And 2 plus 8 is 10, so it has 10 electrons. So therefore, -1 is your charge. And that's how you do this. Now, be aware, full Bohr models are complicated. There's a reason I didn't. Well, they're not complicated. They're just difficult to draw. This is what the full Bohr models look like. So this would be F minus 1, this would be GE, and this would be Na plus 1. And so the Bohr models that we're going to draw look like this on the bottom, right? The real Bohr models actually look like this. So to answer a couple questions, the number of dots around the atom represent the number of electrons in the orbital. The electrons have a tendency to pair up into doubles or pairs until there's not enough of them, hence the valence electrons. They can be paired, they can be combinations of paired and not. I'm not going to explain why they like to couple together, or sometimes they don't. That's a topic that's a little bit more advanced than we need to be. But suffice it to say, if you look at GE and you looked at the first orbital, which is the innermost, there's 2 dots, hence the 2 electrons. The next one's going to have 8 dots. The third one should have 18 in it, and fourth one should have 4 in it. So if you were ever given a Bohr model like this, you should be able to at least count the electrons in each orbital and know how many there are. So if you wanted to draw it out like this, you could do it.